All right, let's dive deep into stargazing and astrophotography.
Sounds good.
We got some really cool sources from astronomerguide.com.
Yeah.
And whether you're just starting out or you've got some experience with a telescope, we're going to try to extract some really cool tips and tricks.
I like it.
So picture this.
Okay.
You're out under the night sky,
Mm-hmm.
and the stars are just shimmering.
Beautiful.
You want to see it in more detail. You want to capture that beauty.
Absolutely.
So let's unlock some of those secrets.
Yeah, we can start with something that really anybody can do.
Yeah.
Even without a telescope.
Well,
The fixed tripod method, it's kind of like the gateway drug to astrophotography.
okay, I'm intrigued.
Yeah, it's all about simplicity.
All right.
You can literally start tonight. All you need is a camera
Mm-hmm.
and a tripod.
Oh, okay.
Or even a flat surface if you're in a pinch.
No telescope.
No telescope.
That's great.
And if you have an old school manual SLR camera,
Yeah.
those are ideal. They have this magical feature called bulb or B mode,
B mode.
which lets you keep the shutter open as long as you want.
Ooh, that's cool.
Yeah, it overcomes the battery limitations of digital cameras,
Okay.
which is really key for these long exposures
Yeah.
that we need to capture faint starlight.
So what can we do with that?
Well, with shorter exposures, you can get some amazing pictures of constellations.
Okay.
You think like 30 seconds.
Mm-hmm.
And the stars look like these perfect pinpoints of light.
Oh, wow.
And you can really showcase those familiar patterns that everybody knows, like
Right.
Orion's belt or the Big Dipper.
Yeah, okay.
But it gets really interesting when you start doing the longer exposures
Okay.
and you unlock the magic of star trails.
Star trails.
Have you ever seen those pictures?
Oh, yeah, they're so cool.
Yeah, they're mesmerizing. They're those streaks of light across the night sky.
Yeah.
And that's basically a visual representation of the Earth's rotation.
Really?
So as the Earth spins,
Mm.
the stars appear to move, and they leave these beautiful trails of light.
I never knew that. So it's the Earth rotating that makes that.
It is, yeah.
Oh, that's amazing.
That's amazing.
So let's say I want to try this tonight.
Okay.
Like, what would be some tips for a total newbie?
Well, first, grab the widest angle lens that you have.
Okay.
That'll let you capture more of the sky
Mm-hmm.
and gather more light, which means brighter stars.
Got it.
And if you're using film, go for a fast one, a high ISO.
Right?
It's like giving your camera a night vision goggle.
Oh, wow. Okay.
Yeah, more light, brighter stars.
So what if I'm in a city, though? Won't the light pollution be a problem?
Yeah, you're right. Light pollution is the arch nemesis of stargazers.
Huh?
So if you can
Yeah.
escape the city lights and head out to the countryside,
Right.
that's where the night sky is truly dark.
Okay.
And you can really capture those epic star trails.
It's an adventure then.
Yeah, it's an adventure.
Go out into the wilderness.
Absolutely.
Any other pro tips while I'm out there?
Yeah, think about where you're pointing your camera.
Okay.
So if you point it east or west, you'll get those cool kind of rain effect with the trails.
Oh, okay.
But if you aim it at the North Star, Polaris, you get these mind-blowing concentric circles.
Oh, so I can change it up just based on where I'm
You
pointing.
can, yeah.
Cool.
And another crucial tip, invest in a cable release.
Okay.
It'll prevent any camera shake
Oh, right.
during those long exposures.
Yeah.
And that'll make sure your images are crisp and clear.
Ooh, shaky stars.
No shaky star.
So for someone who wants to try this tonight,
Yeah.
what's the key takeaway?
You don't need a fancy equipment to start capturing the magic of the night sky.
I love that.
Experiment, have fun,
That's great.
and you'll be amazed by what you can create.
That's really cool.
Yeah.
So what about
Yeah.
taking things up a notch?
All right.
What is this, a focal lunar photography method all about?
So a shoulder.
Does it involve a telescope?
It does.
Okay.
This brings a telescope into the mix. But in a slightly unexpected way.
Right.
It's perfect for capturing those incredible close-ups of the moon.
Oh, lunar close-ups.
Yeah.
Now we're talking.
Yeah, and if your telescope is powerful enough to see the planets,
Yeah.
you can even get some amazing details of those too.
Okay.
But the moon is a great starting point
Oh.
because it's so bright and easy to find.
Makes sense, yeah.
Yeah.
So how does this afocal magic work?
Okay.
So we need like special adapters to connect the camera and telescope?
That's the cool part.
Okay.
You don't need any fancy adapters.
Really?
The term afocal actually means there's no additional lens
Okay.
between your camera and the telescope.
Right.
So you're basically using your telescope as a giant magnifying glass.
Oh, wow.
And your camera lens is basically your eye.
Oh.
Yeah, so you literally hold your camera up to the telescope's eyepiece.
Really?
Yeah, it's that straightforward.
Wow.
And this is where digital cameras really shine.
Okay.
Because you get that instant feedback on the screen.
Yeah.
So you can adjust your position, you can use your zoom
Okay.
until you nail that perfect lunar shot.
So it's all about experimentation,
It is, yeah.
getting it right there on the screen.
And feel free to use your camera's optical zoom
Okay.
to increase the magnification.
Mm-hmm.
Just avoid digital zoom
Okay.
because that can make the image blurry.
Got it. So optical zoom good, digital zoom bad.
Exactly.
But holding the camera up to the eyepiece sounds shaky.
Yeah, you're going to need a tripod here.
Okay.
That's going to keep everything stable,
Yeah.
especially when you're zoomed in.
Mm-hmm.
And to eliminate any vibration from pressing the shutter button, you can use the camera's self-timer.
Okay.
Or, you guessed it,
That cable release.
that trusty cable release.
They're lifesavers.
They are.
Okay. Any other cool tricks for a focal?
So there's actually a device that you can buy
Okay.
that clamps your camera securely to the eyepiece.
Oh, wow.
It's like a little robot hug
Really?
for your camera and telescope. And the best part is it enables auto-guiding.
Auto-guiding.
Yeah.
What's that?
So the telescope actually tracks the moon or the planet for you.
No way.
Yeah.
So it stays focused.
It stays focused.
Wow.
It compensates for the Earth's rotation.
That's incredible.
And it allows you to take super detailed pictures
Really?
with longer exposures.
Wow, that's amazing.
So that's really cool.
So afocal is all about...
It's about taking that next step into astrophotography
Okay.
without needing to invest in a lot of specialized equipment.
Okay, cool.
You can get those incredible lunar and planetary shots.
I like it.
Yeah,
Going from basic to... Now we're using a telescope.
exactly.
Now I want to hear about prime focus.
All right, buckle up.
This is the big one.
This is the big one, yeah.
The most advanced technique.
Prime focus is where things get serious. We're talking about transforming your telescope into a superpowered camera lens.
Okay, so I'm guessing this one we're going to need some more specialized gear.
Yeah, so the key here is
I-
connecting your DSLR camera directly to the telescope.
Okay.
We're basically removing the eyepiece altogether.
Wow.
So with prime focus, your telescope becomes the lens,
Really?
focusing light directly onto your camera sensor.
Wow, that's cool.
Yeah, it's pretty high tech.
So what are some of the challenges of that?
Well, one of the biggest challenges is getting the exposure right.
Okay.
Those fancy light meters on your camera,
Yep.
they're not really designed for the darkness of the night sky.
Right.
So you're going to need to experiment,
Mm-hmm.
take lots of test shots,
Okay.
and find that sweet spot.
So a little more of an art to it than a science.
It is, yeah.
But it's good for bright objects,
It's perfect for bright objects,
like the moon?
like the moon and the planets,
Okay.
especially if you're working with a smaller telescope.
So we're compensating for those shorter exposures with that brightness.
Exactly,
Okay.
yeah.
Any other pro tips for prime focus?
One word,
Okay. Barlow lens.
Barlow lens. I think I've heard of that. It's like adding a turbocharger
Oh, wow.
to your telescope.
Okay.
It increases magnification,
Okay.
allows you to capture all those intricate details.
So we're talking about zooming in even more.
Even more, yeah.
But there's got to be a downside.
Yeah, so it's a classic trade-off in astrophotography.
Okay.
You increase magnification with a Barlow lens.
Yeah.
You sacrifice some brightness. So you're always balancing those two.
magnification versus brightness.
Exactly.
We'll have to play around with that and figure out what's best for us.
Exactly.
But it sounds like prime focus is the one for the serious astrophotographers.
It does unlock a whole new level of detail
Okay.
and precision in your astrophotos.
Wow.
But it requires patience,
Okay.
willingness to learn
Mhm.
and experiment, and maybe a love of tinkering with your equipment
Yeah.
a little bit.
Patience and experimentation.
Yes.
Sounds like the themes of astrophotography.
It is. It's about the journey,
Yeah.
not the destination.
Well said. So we've covered a lot
We have.
from star trails to prime focus.
Yeah.
Before we move on, let's recap these 3 techniques and the key takeaways.
Okay. That's good.
So first up, we had the fixed tripod method.
Mhm.
And that's great for beginners because...
You don't need any special equipment.
Right.
You just need a camera,
Yeah.
a tripod, and a dark sky.
Yeah.
And you can capture those constellations and star trails.
And we learned about the wide-angle lens
Yes.
and the high ISO film,
Absolutely.
minimize light pollution,
Yeah.
cable releases.
Very important.
They are lifesavers.
They are.
Then we went to a focal lunar photography,
Yeah.
which is basically using our telescope as a super magnifier,
A big magnifying glass.
right, by holding our camera up to the eyepiece.
Exactly.
And we learned about the digital cameras
Yeah.
and the instant feedback
The instant feedback is great.
and those adapters. to clamp our camera
Yeah, those are really helpful.
for stability.
Yeah.
And then finally, prime focus,
Prime focus.
where our telescope becomes a powerful camera lens,
Powerful camera lens.
and
Yeah.
we can get those amazing detailed photos.
Of the moon and the planets.
Right.
Yeah.
And that one's for the people who are ready to get really technical.
It is. It's a little more advanced.
It is.
Yeah.
So it's clear that no matter your experience level,
Yeah.
you can capture these celestial wonders
Absolutely.
with the right techniques and a little patience.
It's all about the patience.
It is.
Yeah.
And there's always more to learn and explore.
Speaking of exploring,
I know that.
I'm about to hit you with the final thought-provoking question.
Yes, you are.
So we've talked about all these techniques for capturing the beauty of the cosmos.
Mm-hmm.
They all rely on harnessing light.
Right.
But what are some other ways that we could explore the universe?
Ooh, that's a good question.
Beyond what our eyes or cameras can see?
Yeah.
What about things like radio astronomy?
Ooh, radio astronomy. Yeah.
Exactly.
Cool.
Or something as mind-bending as gravitational waves.
So we're talking about whole other ways of observing the universe.
Entirely different ways.
Wow, that's incredible.
It is.
I'm intrigued.
It's amazing to think about all the unseen wonders
It is, yeah.
that are out there.
Awesome.
Yeah.
Well, we'll leave it on that question.
Yeah.
What other incredible ways can we unlock the secrets of the universe?
It's a question worth exploring.
It is.
Yeah.
And until next time, keep looking up.
Keep looking up.
Keep those questions coming.
Absolutely.
And keep diving deep.
We'll be back soon to talk about those other methods.
Okay.
Awesome. Yeah. You know, it's amazing how these different ways of looking at the universe, they kind of build on each other.
Yeah.
We've been talking about cameras and telescopes capturing light.
Right.
But radio astronomy, it's like opening up this whole new window.
It is a whole new window.
Yeah, into the cosmos.
Yeah.
What's really cool is that radio waves can actually travel through these massive clouds of gas and dust
Oh, wow.
that would block visible light.
So we're seeing things that we couldn't otherwise see.
Exactly. Things that would be completely invisible to us
Wow.
if we were just relying on our eyes or traditional telescopes.
That's incredible. So what kinds of things can we observe with radio astronomy?
Well, the list is vast.
Okay.
You've got everything from pulsars. These are rapidly spinning neutron stars
Okay.
that act like cosmic lighthouses,
Oh, wow.
to active galactic nuclei.
Active galactic nuclei. Those are a mouthful.
They are, yeah, but basically it's a supermassive black hole
Okay.
at the center of a galaxy
Right.
that's gobbling up matter
Oh,
and
all right.
spewing out these jets of energy.
Black holes. Those are always cool.
They are.
What makes them so fascinating to study with radio waves?
Well, as matter falls into a black hole,
Yeah.
it heats up
Okay.
and it emits radiation across the entire electromagnetic spectrum,
Okay.
including radio waves.
So we're basically eavesdropping on a black hole's dinner party.
That's a great way to put it. Yeah, and by studying those radio emissions,
Right.
we can learn a lot about the black hole.
Okay.
Its size, its mass, even how fast it's spinning.
So it's giving us more information than just looking at it through a telescope.
It really is.
Wow, that's incredible.
It's a whole other level.
So it's giving us a deeper understanding of black holes.
It is, yeah.
But can it tell us anything about our own galaxy?
Yes, it can.
The Milky Way.
The Milky Way.
Okay.
So radio astronomy actually allows us to map out the structure of the Milky Way,
Okay.
even though we're stuck inside it.
Right. Right.
We can't get outside of it and take a picture.
How do we do that?
So radio telescopes can detect emissions from hydrogen gas,
Okay.
which is the most abundant element in the universe.
Right.
It's a key ingredient in those massive interstellar clouds where stars are born.
So we're looking at where the stars are born.
Yeah, so by tracking the hydrogen,
Okay.
we can actually trace out those beautiful spiral arms
Oh, wow.
of our galaxy.
That's so cool.
It's like using hydrogen as a cosmic breadcrumb trail
I love that.
to guide us through the Milky Way.
Wow.
Yeah.
Okay, I'm sold on radio astronomy. This is amazing.
It is pretty cool.
But you mentioned something else earlier that was really mind-boggling.
Yeah.
Gravitational waves.
Gravitational waves.
What are those?
These are ripples in the fabric of space-time itself.
Ripples in space-time. Okay, now you're just showing off.
It is pretty wild.
But can you break that down a little bit?
All right, so imagine throwing a rock into a pond.
Okay.
The rock creates these ripples, right, that
Yeah.
spread outward, disturbing the surface of the water.
So those ripples are the gravitational waves.
So these massive cosmic events
Yeah.
are like the rock
Okay.
being thrown into the pond of space-time.
Okay, got it.
And those ripples, those gravitational waves, they travel outward at the speed of light,
Wow.
carrying information.
About what
about the event that created them.
So what kind of events cause this?
So we're talking about things like supernova explosions,
Okay.
black hole collisions,
Yeah.
anything that involves
So big stuff.
big stuff, yeah.
Really big events.
The acceleration of massive objects.
But now we can detect these here on Earth.
We can.
Ow.
It's incredibly challenging
Yeah.
because those ripples are incredibly tiny by
Right.
the time they reach us.
Mm-hmm.
But scientists have built these incredibly sensitive detectors,
Okay.
like LEGO and Virgo,
Okay.
that can measure those minute distortions in space-time.
Wow, that's incredible.
It is amazing.
So how does that help us explore the universe, though?
So gravitational waves provide us with a completely new way of looking at the universe.
Okay.
They allow us to study events
Mm.
that are otherwise invisible to telescopes,
Like what?
like the collision of two black holes.
Oh, right, because they don't emit light.
They don't emit much light at all,
Yeah.
so they're shrouded in darkness.
So it's like we're listening to the universe
Exactly, we're listening to the universe.
rather than looking at it.
It's like a whole other sense.
That's so cool.
Yeah, and we can learn about the properties of those black holes
Right.
involved in that collision.
So their size, their mass.
Their mass, how fast they were spinning,
Okay.
and perhaps even more importantly,
Yeah.
we can learn about the properties of gravity itself.
Wow.
So gravitational waves allow us to test Einstein's theory of general relativity
Wow.
in these extreme environments
That's
where
it.
gravity is incredibly strong.
This is really blowing my mind.
It's pretty amazing stuff.
We've gone from capturing light to now we're listening to the universe.
Exactly. It's like we've unlocked this whole new sensory experience of the universe
Yeah.
that doesn't rely on light at all.
Wow.
And this is a relatively new field,
Okay.
so we're really just starting to scratch the surface.
That's exciting.
It is incredibly exciting.
We're at the beginning of something new,
Absolutely.
and who knows what we'll discover.
We've got no idea what amazing discoveries await us. As we continue to listen to these whispers of gravity
That's so cool.
from across the cosmos,
It's both exciting and humbling to realize how much we still don't know,
it really is.
but that we're pushing the boundaries of that understanding.
With all these incredible tools, we
Yeah.
are, and each new discovery brings with it a whole wave of new questions,
It does.
driving us to explore even further.
Well, we started our deep dive talking about those 3 astrophotography techniques,
Yeah,
and then we went to radio astronomy,
that's right.
and now we're talking about gravitational waves.
Yeah.
We've covered so
It
much.
feels like we've traveled across the universe.
Yeah,
Yeah.
but there's always more to explore.
Always more to explore.
Our journey's not over.
Far from over.
So, what other amazing ways are there to unlock the secrets of the universe?
Mm.
It's amazing, we've gone from just like capturing starlight with our cameras to decoding whispers of gravity from across the universe.
It really is remarkable.
It's mind-blowing all these different ways we can explore the cosmos. But let's bring it back down to Earth for a second.
Okay.
For those of us who are just starting out,
Yeah.
what are some practical tips for beginners?
Well, it's easy to get caught up in all the technical details and the fancy equipment.
Right.
But I think the most important thing is to just start simple
Okay.
and have fun.
Yeah.
You don't need a fancy telescope or a degree in astrophysics
Right.
to enjoy the wonders of the night sky.
Absolutely. So
Yeah.
what would be like the most accessible way for someone to dip their toes in?
Just spend some time under the stars
Okay.
with your naked eyes.
Right.
Get familiar with the constellations.
Mhm.
Learn to identify some of the brighter stars and planets.
Okay.
It's like learning the neighborhood
Right.
before you start exploring the whole city.
Creating that mental map
Exactly.
of the night sky.
And there are some great apps and websites now
Oh, yeah.
that can help you along the way.
Yeah, those stargazing apps are amazing.
They're incredible. You just point your phone at the sky, and it'll tell you exactly what you're looking at.
I love that.
Some of them will even show you the paths of satellites
Wow.
and the International Space Station.
Oh, that's so cool.
Yeah, it's pretty
I
amazing.
remember the first time I saw the ISS, I thought it was a shooting star.
Yeah,
But then I was like, wait a minute, that's moving way too fast.
it does move pretty quickly across the sky.
Yeah, and once you're comfortable navigating the night sky
Mm-hmm.
with your eyes, then you can start experimenting with astrophotography.
Absolutely. You can try that fixed tripod method.
Right, to get those star trails.
Exactly.
That's a great way to start.
Yeah, and you'll learn those fundamentals of long exposure
Right.
and create some really cool images.
Yeah, but we got to get away from those city lights.
You do. Light pollution is the enemy
It is.
of stargazers.
It is.
Even a short drive away from the city
Yeah,
can make a huge difference
it really can.
in the number of stars that you can see.
It's like night and day.
It really is.
But what if you can't get out of the city?
Well, most cities have local astronomy clubs.
Oh, okay.
They host stargazing events.
All right.
It's a great way to meet other people
Yeah.
who share your passion. You can get a glimpse of the universe through their telescopes.
So it's kind of like a support group for stargazing enthusiasts.
It is. It's a community.
Love it.
And then, of course, there's a wealth of information online.
Oh, yeah.
Countless websites, forums,
Yeah.
YouTube channels
Mhm.
dedicated to all this stuff.
You can learn so much from home now.
You really can.
It's incredible.
It's amazing how accessible all this information is.
We're lucky to live in this time
We are.
where it's so readily available.
And as you learn and grow as a stargazer,
Yeah.
remember to embrace that sense of wonder.
Okay.
Keep experimenting. Try new techniques, new equipment, new locations.
It's all about the journey, right?
It's all about the journey.
Yeah.
There's always something new to discover out there.
I like that. That's what the deep dive's all about.
Exactly.
Exploring new ideas
Pushing the boundaries.
and keeping that sense of wonder.
Absolutely. Whether you're capturing those stunning photos of the Milky Way
Yeah.
or just marveling at the constellations, there's a whole universe out there waiting to be explored.
Well said. So for all of our listeners out there
Yeah.
who are ready to embark on their own cosmic adventures, what's the one thing to remember?
Keep looking up,
Okay.
stay curious, and never stop exploring.
I love it.
The universe is full of incredible secrets
It is.
waiting to be uncovered.
Well said. Keep diving deep, everyone.
Keep diving deep.
This is The Deep Dive signing off.